Hi everyone. In this lecture, we will understand all the set operations. We have already seen the definition of all the set operation like union, intersection, set difference, symmetric difference. Okay. So now in this lecture, we will understand all these set operation. We will just understand quickly. So first is our union. If you have two set A comma B, okay, so this A comma B, these are, let's assume these are two set. They can be same or different. So you have two set A comma B. Then what is their union? Their union represents the set. Their union is also a set. Okay, so this represents a set that you get when you combine everything from A comma B together. So every element of A, every element of B you take, okay, that is your union of two set. So I can simply say that an element belongs to A union B if and only if X belongs to A or X belongs to B. So this is the idea. So what I can say? I can say that you have some element, okay, that will belong to A union B if and only if. When it will belong? It will belong if and only if X belongs to A or X belongs to B. So this is the idea. So basically the idea is this. See, if X belongs to A or X belongs to B, okay, then what can I say? Then I can say that X belongs to A union B. Similarly, I can also say the reverse direction. I can also say that if X belongs to A union B, then what can we say? Then we can say that definitely X either belongs to A or X belongs to B or X belongs to both. Okay, so this or, this is basically inclusive or. By default, or means inclusive or. So it means that X belongs to A union B, then X belongs to A or X belongs to B or X belongs to both A comma B. So this is the idea. Now, very important. If X belongs to A, then can we say, if X belongs to A, then can we say that X belongs to A union B? Correct? Yes, because see, if X belongs to A, then definitely X will be in A union B. X belongs to A, then in A union B, you will definitely have X. So this is the idea. If X belongs to A, then I can say that X belongs to A union B. But remember, the reverse direction is not correct. This direction, if X belongs to A union B, X belongs to A union B, then can we say that X belongs to A? Can we say X belongs to A? No, this we cannot say because maybe X belongs to B. See, X belongs to A union B. Okay, then can I say X belongs to A? No, because maybe X belongs to B. If X belongs to B, then also I can say X belongs to A union B. So basically, if X belongs to A, then definitely I can say that X will belong to A union B. But if X belongs to A union B, then I cannot say that X belongs to A. This statement I cannot say. If X belongs to A union B, then I can say that X belongs to A or X belongs to B. So this is the idea. This is from union. Simply I can say that if X does not belong to A, then can I say that X does not belong to A union B? Can I say this? If X does not belong to A, then can I say X does not belong to A union B? No, I cannot say this. This statement is not correct. Maybe X belongs to B. So this is the idea. Similarly, okay, now see this statement. If X does not belong to A, but X belongs to A union B, then what can we say? Then what can we say? Think about it. X does not belong to A, but X belongs to A union B. Then what can we say? We can say that X belongs to B. So this is correct. Okay. So these are some ideas basically from the union. From the union, you can notice in A union B, we have all the elements of A. Also, we have all the elements of B. So we combine everything from A and B in our union. So from these some statements we can use. Remember, understanding all these operations, this is very important when we see the proof of set equality. When we want to prove that okay, two set are equal, when we want to prove this, then these understanding of these set operation, that is extremely important. Okay, so understand all these statements that I'm writing on screen. Okay, now let's go to the next operation, that is intersection. What is the definition of intersection? So the definition of intersection is basically I can say that X belongs to S intersection T. What it means? Then can I say if X belongs to S intersection T, then what can you say? You can say that X belongs to S and X belongs to T. Because remember, this is intersection. Intersection means we have all the common elements. This is the definition of intersection. In the intersection, we have those elements which are in S and which are in T. So the common elements of S, common elements of T. Okay, so the elements which are common in S comma T, the elements which are both in S and T, okay, those elements we have in intersection. This is the definition of intersection. So I can say that if X belongs to S intersection T, then I can say that X belongs to S, and I can say that X belongs to T. Similarly, if X belongs to S intersection T, then definitely I can say that X belongs to S. This is also correct. Okay, because of course, if X belongs to the intersection, then definitely X belongs to S, also X belongs to T. So I can say that if X belongs to S intersection T, then X belongs to S. The same statement can I write in the reverse direction? Can I say that if X belongs to S, then can I say X belongs to S intersection T? Is this statement correct? Think about it. X belongs to S, then can I say that X belongs to S intersection T? This statement is false because maybe X is not in T. If X is not in T, then definitely X will not belong to S intersection T. So this statement is false. And what about the reverse of this statement? If I say that X belongs to S and X belongs to T, if this I say, then what can you say? X belongs to S and X belongs to T. Then I can definitely say that X belongs to S intersection T. Okay, because X is in S comma T. X is present in both these set, so X will be present in the intersection. This is the idea. And if X does not belong to S, then what can you say? Then I can definitely say that X does not belong to S intersection T. Because if X is not in S, then X is not common between S comma T. So I can say if X is not in S, then X is not in S intersection T. So these are some ideas. What about okay, what about this direction? If X does not belong to S intersection T, then can I say that X does not belong to S? Is it correct? So this is correct, but is this correct? This statement on your screen, is this correct? X does not belong to S intersection T. Then can I say X does not belong to S? No, I cannot say. Maybe X is not in T. Maybe X is in S, but X is not in T. Because you can notice X does not belong to the S intersection T. Okay, so from this we cannot say that X does not belong to S. Maybe X belongs to S, but X does not belong to T. Okay, so these are some ideas. The next definition that we have, that is set difference. This is the definition of set difference. What we have in S minus T? In S minus T, we have those elements which belong to S but do not belong to T. So this is the definition of S intersection T. You know what is S intersection T? So if this is the set S and let's assume this is the set T, then S intersection T means those elements which are only in S, those elements which are in S but not in T. Okay, those elements which are only in S, these elements, these are called, these elements are basically in S minus T, set difference. Okay, another symbol for set difference is basically this is the same as, this is same as this is another symbol for set difference. Both these are same. This is just a symbol for set difference. Anyway, now from this you can notice that if X belongs to S and X does not belong to T, then I can definitely say that X belongs to S minus T. Correct? Because you can notice X belongs to S, X does not belong to T. Then I can say that X is only in S, X is not in T, X is only in S. Then definitely X belongs to S minus T. And the reverse direction is also correct. If X belongs to S minus T, then I can definitely say that X belongs to S, and I can say that X does not belong to T. Okay, what about if I know that X does not belong to S, then what can I say? Think about it. Okay, X does not belong to S. If X does not belong to S, then definitely X does not belong to S minus T. Because remember, when S will be in, okay, when X, so tell me, when X belongs to S minus T, when it will happen? When it will happen that X belongs to S minus T? It will happen only if, okay, if and only if X belongs to S and X does not belong to T. Okay, so in this situation X will belong to S minus T. Now we are saying that X does not belong to S, then definitely we can say that X does not belong to T. X does not belong to S minus T. Similarly, okay, so this statement, all these statements, these are correct. Now, similarly, if X does not belong, okay, so if X belongs to T, then what can we say? Think about it. X belongs to T, then definitely X does not belong to S minus T. because x will belong to s minus t if and only if x belongs to s, x does not belong to t. So you can notice if x belongs to t, then definitely x does not belong to s minus t. So these are important. If x does not belong to s, then also I can say that x does not belong to s minus t. Okay, but in the reverse direction, can I say if x does not belong to s minus t, then can I say that x does not belong to s? Is this statement correct? This statement is not correct. Why? This statement is not correct because x does not belong to s minus t. It means, okay, maybe x belongs to t, maybe x belongs to s, also x belongs to t. Okay, so this is the idea. So similarly, x does not belong to s minus t, then what can I say? Okay, if x does not belong to s minus t, so this is your s minus t. This area which is only in s, this area is s minus t. Okay, now x does not belong to s minus t if and only if. What can you say about x? Either x belongs to t, because you can notice if x belongs to t, then you can notice that x is not in s minus t. So either x belongs to t, or x belongs to s bar, or x belongs to s bar. Okay, so this is the idea. So this is the simple idea that x does not belong to s minus t if and only if x belongs to t, or x does not belong to s. Okay, so here I can say that x does not belong to s minus t if and only if. Here we can use the word if and only if x does not belong to s, or x belongs to t. Okay, so this is how you can understand all the set operations. Each and every set operation you should understand. Now the next set operation is symmetric difference. What is the definition of symmetric difference? This is the symmetric difference. Uh, this is the definition of symmetric difference. A symmetric difference B. What that means? So we have those elements which are exactly in one of the sets. Okay. This basically those elements which are in A but not in B, or which are in B but not A. Basically the symmetric difference, I can say A symmetric difference B. This has those elements which are in exactly one of these sets. Okay. So if some element is in A but not in B, then it will be in the symmetric difference. If some element is in B but not in A, then it will be in the symmetric difference. Basically A symmetric difference B, that means A minus B union B minus A. So this is the definition of symmetric difference. A minus B union B minus A. So if x does not belong to A but x belongs to B, then what can you say? Then we can definitely say that x belongs to B minus A, because you can notice x belongs to B, x does not belong to A. Definitely x belongs to B minus A. Okay, similarly, because x belongs to B minus A, then I can also say this same statement. I can also say that x does not belong to A, x belongs to B. Then I can also say that x belongs to A symmetric difference B, because remember the symmetric difference is basically union of A minus B comma B minus A. So in this situation x will belong to B minus A. Because x belongs to B minus A, so definitely x also belongs to A symmetric difference B. But the reverse direction is not correct. Okay, so you can notice this reverse is correct. If x belongs to B minus A, then I can definitely say that x belongs to B and x does not belong to A. This is correct. All these are correct. But notice the reverse direction of this statement is not correct. If I have x belongs to A symmetric difference B, then can I say that x does not belong to A, x belongs to B? Can I say this statement? This statement I cannot say, because if x belongs to A symmetric difference B, then maybe x belongs to B minus A, or maybe x belongs to A minus B. Okay, so you can notice the symmetric difference is union of this union this. I can say in the symmetric difference we have those elements which are in exactly one of these set. Okay, so if x belongs to symmetric difference, then maybe x belongs to A but x does not belong to B. Okay, so this statement is not correct. So this is how you can understand each and every operation. Okay, so each and every set operation you should understand very clearly. Similarly, if you want to prove, okay, let's assume if you want to prove that x belongs to A union B, then how will you do that? If you want to prove that x belongs to A union B, then how are you going to do that? To prove x belongs to A union B, then what you do? The idea is this. It's very simple. If you want to prove that x belongs to A union B, then prove that x belongs to A, or prove that x belongs to B. This is the idea. Okay, if you want to prove x belongs to a union b, then prove that x belongs to a or x belongs to b. Either this you prove or this you prove, because if x belongs to a, then automatically x belongs to a union b. If x belongs to b, then automatically x belongs to a union b. Okay, so either you prove this or you prove this. Okay, whichever is simple, you can do that. Okay, so to prove x belongs to a union b, this is the idea. Okay, let's see the next one. If you want to prove that x belongs to a intersection b, then what to do? In this situation, what you have to prove? You want to prove that x belongs to a intersection b. Then what you have to do? You have to do that x belongs to a, and you have to prove that x belongs to b. So you have to prove this, you have to prove this, both of them you have to do. Okay, so this is the idea. You have to prove this one, both of them you need to prove. Similarly, if I want to prove that x belongs to a minus b, then what is the idea? Then the idea is simple, that x should belong to A and x should not belong to B. X should not belong to B. So this is clear. Because if x belongs to A minus B, if you want to prove that x belongs to A minus B, then definitely I should prove that x belongs to A. I should also prove that x does not belong to B. If you want to prove that x belongs to b minus a, then what you have to do? Then you have to say that x belongs to b, and you have to prove that x does not belong to a. Okay, so you have to do this and you have to do this. Okay, so this is the idea. Similarly, finally, if you want to prove that x belongs to a symmetric difference b, if you want to prove this one, then what you have to do? Then either you do this or do this. Okay, so either you do this, you prove that x belongs to a. Okay, you prove that x belongs to a, but and x does not belong to b, and x does not belong to b. So either you do this or you do this, x does not belong to a and x belongs to b. Okay, so what you have to do? Either you do this or you do this. Okay, so one of them you do. Okay, so either you do this one or you do this one. So this is the idea. If you want to prove that x belongs to symmetric difference, because x belongs to symmetric difference of a comma b, that means x is in exactly one of these set. Okay, x cannot be in both of them. Okay, x should be in exactly one of them. Either x is only in a or x is only in b. Okay, so this is the idea. So this is what you have to do if you want to prove these things. Now next, very important. Okay, let's see. If x does not belong to a minus b, then what can you say about this? If x does not belong to a minus b, then what can I say? X does not belong to a minus b. Then we have already seen that maybe x belongs to a. Okay, x does not belong to a minus b. Then what it means? It means that maybe x does not belong to a, or maybe x belongs to b. See, if x does not belong to a, then automatically x does not belong to a minus b. Also, if x belongs to b, then automatically x does not belong to a minus b. So if x does not belong to a minus b, then I can say that x does not belong to a or x does not belong to b. Okay, so this is the simple idea. Similarly, if I want to say that x does not belong to a intersection b, then what it means? Then it means that either x does not belong to a or x does not belong to b. Okay, because if x is not common, if x is not common in a comma b, then what it means? It means that either x is not in a or x is not in b, or both. This or is inclusive or. By default, or means inclusive or. So either x does not belong to a or x does not belong to b, or maybe both of them, x does not belong to a and x does not belong to b. So this is the idea. Similarly, if x does not belong to a union b, then what can we say? Then we can say that x does not belong to a and x does not belong to b. Because if x does not belong to union, what it means? X is not in union. It means that x is not in a, also x is not in b. So x is not in a and x is not in b. Okay, now similarly, if x does not belong to, if x does not belong, let's assume does not belong to symmetric difference, then what can we say? X does not belong to symmetric difference. It means either x is in both of them or x is in none of them. Okay, so basically these two things will happen. Then I can say either x is in both of them, either x is in intersection, or x is not in any of them. X is not in any of them. So this is the idea. You can notice, if x does not belong to symmetric difference, what it means? It means that either x is in both of them, either x is in a intersection b, means both of them, or x is not in any of them. X is not in A, x is not in B, x is not in any of them means x is not in A union B. Okay, so in this situation I can say x is not in the symmetric difference. So this is the idea. Okay, so this you can see quickly. Let p comma q comma r, these are set. If A belongs to P, then I can definitely say that A belongs to P union Q, because if A is in P, that is enough. That is enough for A to be in P union Q. So this statement is correct. Next, if A does not belong to P, then X definitely does not belong to P intersection Q. Okay, because if x is not in P, definitely x is not common in P comma Q. So I can say if A does not belong to P, if A does not belong to P, then A does not belong to P intersection Q. If A does not belong to P union Q, then I can definitely say that x is not in any of them. X is not in P and x is not in Q. Okay, so this is the idea. Now A belongs to P union Q, P intersection Q, it means A is in P, also A is in Q. A does not belong to P intersection Q. It means A is either A is in either A is not in P or A is not in Q. Okay, so this comma means and. So this is the idea. Okay, so this is very important, that if you say that X does not belong to P, then what are the things that you can say? Then what are the things? Then I can definitely say that X does not belong to P intersection Q. Okay, so then I can say this. But can I say this? X does not belong to P union Q. Can I say this? Can I say this? X does not belong to P union Q. Can I say this? This I cannot say. Okay, what about this? X does not belong to P minus Q. See, if X is not in P, then definitely X is not in P minus Q. So this is also correct. Okay, so these are some correct statements. If X does not belong to P, then these are some correct statements. Okay, now further, if X belongs to P, then what can I say? Then I can say that X does not belong to P bar. Okay, P complement. If X is in P, then definitely X is not in P bar. Okay, because if this is your P, let's assume this is the set P. Let's assume this is set P. Now this area is P. This area is P, and you can see this area is basically P bar. This green area is a P bar, and okay, this area is P. So you can notice if X belongs to this area P, then definitely X does not belong to the area P bar. If X is here, then X is not in P bar. Similarly, if X is not in P, if X is not in this area, then definitely X is in P bar. Okay, similarly, if X is in P bar, if X is in P bar, then I can say X is not in P. Also, if X is not in P bar, then I can say X is in P. Okay, if X is not in P bar, then definitely X is in P. Okay, so this is the idea. Remember, remember X is either, always one of these things will always happen. Okay, one of these things. Always this will happen, that either X will be in A or X will be in A bar. This statement is true. This statement is always true. Okay, because any element, whatever element you take, either it is in the set or it is not in the set. Either it is in the set A or it is not in the set A. Either it is inside the set A or it is outside the set. Okay, so this is the point. X belongs to A or X belongs to A bar. This is definitely correct, because remember what this means. This means X belongs to A, or what this statement means, X belongs to A bar. What it means? It means X does not belong to A. So either X is in A or X is not in A. This statement is definitely true, always true. Okay, so this is the idea. So all these four, these are correct. Now let's move on. Let's see this one. If if element A belongs to P union Q, then what can you say? Then I can say A belongs to P or A belongs to Q. A belongs to P minus Q. Then I can say A belongs to P and A does not belong to Q. A does not belong to Q. What it means? What it means? What it means? It means A belongs to Q bar. It simply means that A belongs to Q bar. Okay, A does not belong to Q, it means A belongs to Q bar. So I can say that A belongs to P minus Q if and only if I can say A belongs to P and A belongs to Q bar. Okay, because this statement, remember, this statement is same as I can also say that P minus Q if and only if A belongs to P and A does not belong to Q. A does not belong to Q. And these statements are same basically. This statement and this statement, these are actually same statements. Okay, so this is the idea. A does not belong to P minus Q. What it means? It means A does not belong to P, or A belongs to Q. A belongs to P, then definitely A does not belong to P bar. A does not belong to P, then definitely A belongs to P bar. Next, let's see this one. A belongs to, this is the symmetric difference. This is another symbol for symmetric difference. So either you can use this symbol for symmetric difference, or you can use this symbol for symmetric difference. This exclusive or symbol we can use for symmetric difference. Why we are using this symbol? Because this symmetric difference means that element X is in exactly one of them. Okay, either it is in only P or it is only in Q. It cannot be in both. Also X should be in one of them. Okay, exactly one of them. So this is the idea. So this P exclusive or Q, it means that, what it simply means, you already know, it simply means that either either the element is in P and not in Q. Okay. Either the element should be in P but not in Q, or the element should be in Q but not in P. Okay. So this is the, anyway, this is the idea. Now let's see. If X belongs to this, then what can we say? Then we can okay, if these two things happening, if these two things happen, A belongs to P XOR Q and A belongs to P, then it means that A does not belong to Q. Okay, similarly, A does not belong to Q, A belongs to P, then what can you say from these two? From these two, what can you say? I can say that A definitely belongs to P XOR Q. Okay, P symmetric difference Q. The next one, if X belongs to power set of Q. Okay, if this element belongs to power set of Q, power set, what this means? This means power set of Q. Okay, so let me just take power set of A. So first of all, what this means? This means the power set of A. What is power set of A? That is a set of all subsets of A. So if X belongs to power set of A, then what it means? Then it means that X is a subset of A. Because if X is in power set of A, it automatically means that X is subset of A. Also, if X is subset of A, then I can say X is in power set of A. So if X is in power set of Q, then X is subset of Q. Okay, the reverse direction is also correct. I can say that if X is subset of A, let's assume if X is subset of A, then I can definitely say that X belongs to power set of A. Okay, so this is the idea. Let's move on. Let's see this one. If X does not belong to the power set of A, let's assume X does not belong to power set of A, then what can you say? Then what can we say? It simply means that X is not a subset of A. Because if X is subset of A, then definitely X will be in power set of A. So if X is not in power set of A, then I can say X is not a subset of A. Similarly, if X is not a subset of A, if X is not a subset of A, then definitely X is not in a power set of A, because in the power set of A, you have all the subsets of A. In this, you have all the subsets of A. So that's the reason. If X is not subset of A, then X is not in the power set of A. So I can simply say that X is in power set of A if and only if X is a subset of A. So this is a if and only if statement. Okay, next. So this you can see X belongs to power set of Q. It means X is subset of Q. So this is if and only if statement. This will imply this. This will imply this. Okay. Now let's see this. If whenever X belongs to A, then X belongs to B. This is the definition of subset, because this is the definition of subset. A is subset of B. It means whenever some element belongs to A, then it also belongs to B. Or I can say every element of A is in B. So this statement is saying if whenever X belongs to A, then X belongs to B. Then this is the definition of subset. So I can say basically A is subset of B. Next, this one. This is important. A minus B, that is same as B bar minus A bar. Okay, how can you see this? So basically A minus B, this is same as B bar minus A bar. B bar minus A bar. Okay, so how can we prove this? Very easy, because we have already seen that A minus B is same as A intersection B bar. Okay, because what is A minus B? From the Venn diagram you can notice this. If this is set A, let's assume this is set B, then what is A minus B? Okay, which area is A minus B? This area is basically the A minus B area. And which area is A intersection B bar? So you can notice, let me call this area 1. Okay, and so let me call this area 1, let me call this area 2, let me call this area 3, let me call this area 4. Then which area will, okay, so which area is A minus B? A minus B is the area 2. Okay, so this area 2 is the A minus B, because this is the area 2. Now which area will come in A intersection B bar? A intersection B bar means the common area of A comma B bar, the area which is in A, okay, also which is in B bar. Okay, so the area which is in A but in B bar means which is not in B, which is in A but not in B, so that area is basically area 2. A intersection B bar means the common area of A comma B bar, the common area of A comma B bar, this is the area of A. Okay, in this area the common area which is which is common with B bar, the, okay, so the common area with B bar is only this one. Okay, so I can say this A intersection B bar is also area 2, and this A minus B, this is also area 2, so I can say both are same. Okay, so this method we can apply basically. Okay, A minus B, that is same as A intersection B bar, so you can apply this here. What is A minus B? That is same as A intersection B bar. And what is B bar minus A bar? B bar minus A bar, what is that? That is basically B bar intersection A. Both are same. A intersection B bar is equal to B bar intersection A. So this is the idea. Okay, I hope this is clear to everyone, because A minus B, that is same as B bar minus A bar. Why? Because this, okay, this one, this is same as A intersection B bar, and this is same as B intersection, okay, B bar intersection A, and you can notice both are same. So that's the reason. So I can say A minus B, this is same as B bar minus A bar. Next, this is the definition of exclusive OR. Okay, so A exclusive OR B, that means A minus B union B minus A, this we have already seen. Also A exclusive B, A symmetric difference B, that is basically A union B minus A intersection B. Why? Because from the Venn diagram again you can notice, if this is the area A, this is the area B, then what is the symmetric difference area? The area symmetric difference means A exclusive over B. This area is basically this area. This white area is A exclusive over B, because it says that the area, okay, those elements which are in exactly one of these, those elements which are only in A or which are only in B. So this area is your symmetric difference area. Okay. Now similarly, what is the area by A union B minus A intersection B? So from this A union B, this is the area of A union B. From this area, if you remove this common area, so from this complete area, you remove this common area, then what area you will get? You will get this same area, this A minus this A symmetric difference B, this same area you will get. So A union B minus A intersection B, this area is basically your symmetric difference area. So these two we have seen. Next, A minus B is same as A union B minus B, because what is A minus B? Okay, so if this is the set, if this is set A, and let's assume this is set B, then what is the area of A minus B? So A minus B area, you can notice, let me call this area 1, area 2, area 3, area 4. So then you can notice A minus B, that is the area 2, that is same as area 2. Now what is A union B? A union B, A union B basically means 2 3 4, this area 2 3 4, this is A union B. Okay, and what is the area A? Area A is 2 comma 3. What is area B? Area B is basically 3 comma 4. So what is A minus B? A minus B is only 2. So I can clearly say that what is A union B minus B? What is A union B minus B? This is A union B. From this you remove the area of B. From this A union B, this is A union B. From this you remove the area of B. Then what you will get? You will get the area 2. Okay. So this is what I am saying, that A minus B, this is same as A union B minus B. Okay. This A minus B, this is A minus B. This is same as A union B. From the union, you remove the area of B. This area of B you remove. Okay, so these are some properties that we have seen. Now let's see this next one. A exclusive or B, that is same as B exclusive or A, that is correct. Next, if A is subset of B, then what can you say? If A is a subset of B, okay, then what we can say? Let's assume A is subset of B, means every element of A is in B. Every element of A is in B. So then what we can say? Then you can clearly see A minus B, that will be 5. Okay, A minus B area, that will be 5, because every element of A is already in B. Okay, so there is no element which is in A but not in B. There is no element which is only in A. So I can say A minus B, that is basically 5. If A is subset of B, then A minus B is 5. Similarly, if A is subset of B, then definitely A will belong to power set of B. A will belong to power set of B. Next, this is the De Morgan law. If some element does not belong to union, then what can you say about this? Okay, so if some element does not belong, if some element, let's assume if some element does not belong to A union B, then what can we say? X does not belong to A union B. Then what can we say? Then we can say that X does not belong to A and X does not belong to B. This is what we can say, correct? If some element does not belong to union, then what you can say? Then I can say that X does not belong to A and X does not belong to B. Similarly, if X does not belong to A and X does not belong to B, then I can say X does not belong to A union B. So I can put if and only if here, basically, because if this happens then this will happen, if this happens then this will happen. So this is the idea. So I can say X does not belong to A union B, that means X does not belong to A and X does not belong to B. This statement, I can say that X belongs to A union B complement. Okay, X does not belong to A union B, it means X belongs to A union B complement. Okay, if and only if X does not belong to A, it means X belongs to A complement. And X does not belong to B, it means X belongs to B complement. Okay, now X belongs to A complement, this is and means intersection. So I can say X belongs to A bar intersection B bar. Okay, so if X belongs to A union B bar, if X belongs to A union B complement, if and only if X belongs to, X does not belong to A and X does not belong to B, basically X belongs to A bar intersection B bar. This is also known as De Morgan law. Okay, this rule is basically called De Morgan law. Basically A union B, okay, this complement, this is same as A complement intersection B complement, this is known as De Morgan law, and this is the proof. The proof is very simple, because okay, we have already seen all of them. A does not belong to this. It automatically means that A is not in this, X is not in A, X is not in B. Okay, so this is how you can do. Similarly, if X is okay, similarly, now tell me, if X is not in, let's assume X is not in A intersection B, then what it means? Okay, X is not in A intersection B. What it means? It means that X is not in A or X is not in B. Either X is not in A or X is not in B, because X is not in this intersection. It means that either X is not in A or X is not in B. What this means? This means that X belongs to A intersection B complement. If and only if X does not belong to A, it means X belongs to A complement. Or X does not belong to B, it means X belongs to B complement. Okay, now what this means? X belongs to A complement or X belongs to B complement, it means X belongs to A complement union B complement. Okay, if and only if X intersects. Okay, so this is the idea. If X belongs to A intersection B complement, if and only if X belongs to A complement union B complement. Okay, so this is the rule. Basically I can say that A intersection B complement, that is same as A complement union B complement. These two rules we call them De Morgan law. Okay, these two rules are called De Morgan laws. Next, A minus B is same as A intersection B bar, or also, okay, so this asymmetric difference, this asymmetric difference B, when can I say some element belongs to asymmetric difference B? When it will happen that some element will belong to asymmetric difference B? It will happen when, okay, either this happens or this happens, means either the element belongs to A and not in B, or the elements belong to B and not in A. Okay, so this is the idea. Okay, X belongs to A symmetric difference B, it means X belongs to A and not in B, or X belongs to B and not in A. So either X is only in A or X is only in B. So this is the idea, this is the symmetric difference rule. Okay, so all these rules that we have seen, all these properties that we have seen, okay, these are very important when we prove set equality. All of them, like X belongs to A union B, it simply means X belongs to A or X belongs to B. X does not belong to A union B, it means X does not belong to A and X does not belong to B. X belongs to A intersection B, it means X belongs to A and X belongs to B. X does not belong to A intersection B, it means either X does not belong to A or X does not belong to B. X belongs to A minus B, it means X belongs to A and X does not belong to B. X does not belong to A minus B, it means either X does not belong to A or X belongs to B. Okay. Similarly, the cross product. If X belongs to cross product, it means X is a ordered pair. It means because if X belongs to the, okay, so this is the definition of cross product, A cross product B. What this means? In this we have ordered pairs, A cross product B. In this we have ordered pairs where the first element will come from A, the second element will come from B. So this first element, this will come from A, and the second element will come from B. So this is the idea. Okay. Now, 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 if some element, let's assume if some element belongs to A cross B, if some element is in A cross B, then what it means? Then what it means? It means if some element is in A cross B, then what it means? It means that this is a ordered pair. This X is a ordered pair. Okay, where this first element is coming from A and this second element is coming from set B. So you can notice if X belongs to A cross B, then it means X is a ordered pair. Okay, for some this A comes from set A and this B comes from set B, and this is the definition of subset. A is subset of B. It means whenever X belongs to A, then X belongs to B. Okay, and the definition of equality, when can I say A is equal to B? A is equal to B, it means A is subset of B and B is subset of A. Okay, so all these are very important. The understanding of all these operations, understanding the set operations, this is extremely important when we, okay, when we solve the questions related to set equality. You have two set, and okay, they ask you whether they are equal or not, whether one of them is subset of another or not. Okay, so whenever you want to prove set equality or set containment, basically the subset type of things, whenever you want to prove, then this understanding of set operation is extremely important. So whatever we have seen in this video, okay, understand everything. Okay, all the variations I have taken, every variation you try to understand. Okay, and if you understand everything, then basically you understand set theory. Okay, so this video is extremely important. Okay, if you understand set theory, if you want to understand set